Okay, so this unit pretty much goes over finding the error. What did this person do wrong? You can see they factored the top, factored the bottom, make sure they factored correctly. If you do not remember how to factor, let me know. I do have factoring videos. I'm factoring this trinomial here, making sure they factored correctly. Looks like they did. X cannot equal 2. It looks like this person find excluded values. So yeah, if we were to plug in 4 in the numerator, it would give us 0 for the numerator. And anything divided by 0, so whatever the denominator would then be like 0/8, that would get us 0. X, she didn't exclude x equals 0. She didn't factor the denominator correctly. Let me see what she did wrong. Yeah, here x can also not equal 4 because then it would 0 out. If you were to plug it in a 4 in here, it would 0 out. So she didn't exclude x. She did everything right except she didn't exclude x to equal 4. So for those, you're just trying to see what the person did wrong. I'm not really too concerned about these. You should probably just like learn how to convert to do these in lowest terms. That is more important. So let's factor the top here. That would get us a 4 and a -4, which would get us -2, -2, which would then get us x minus 2 times x minus 2. So the top is factored. Let's factor the denominator. Factoring the trinomial. This would get us x plus 7, x minus 2, and you can cancel out the 2's. So you have x minus 2 over x minus 7. So that's in lowest terms. You always cancel out what they have in common, top and bottom. And you can see the denominator, x cannot equal -7 or 2. And also, what did we do? Oh, this should be an x plus 7. Sorry, I entered that wrong. But, oops, entered it wrong again. I'm just having a moment. There we go. So that's the answer. Pretty simple. You just factor, cross out, see what the denominator cannot equal. Very simple. In behavior of rational functions. So consider the rational function. Determine the in behavior. So f of x can be, okay, so first let's look at this. Let's factor the top and the bottom. If we factor the top, we can take out an x. Actually, I don't think they want you to factor. There's another way. Let's double check. Okay, so Khan Academy here does it another way, but basically if f of x as x becomes negative, what does y become? And x becomes positive, what does y become? So basically if you were to plug in, a negative value for x, what would your, as it becomes more and more negative, what would your y be? As it becomes more and more positive, what would your y be? And you could plug in, values for x, or you can do it a different way. Okay, so we want to look at the highest term in the denominator, which is x to the 4th. And we basically want to multiply top and bottom by 1 over x to the 4th. So we're going to multiply that top and bottom. So basically you're dividing top and bottom by x to the 4th. So x to the 4th over x to the 4th gets you 1 minus 4x to the 3rd over x to the 4th gets you 4 over x plus 6 over x to the 3rd. And then for the denominator, you have -5 plus 8 over x squared minus 3 over x to the fourth. So I'm basically just taking each term and I'm dividing it by x to the fourth for each one, top and bottom. So don't worry about these. As for all of these, when you divide them by, you know, bigger and bigger numbers, they just get closer to 0. So that's a little trick with those ones. So you can even check if you did 4 divided by a million or 1,000, and then keep going up and up. 4 divided by 100 gets me 0.04. 4 divided by 1,000 gets me 0.004, and then it's going to just get closer and closer to 0. So the numerator looks like it would be 1, and then the denominator looks like it would be 5. So as x gets closer and closer to a negative number or positive, we just get closer and closer to negative 1/5. And that's the shortest way to do it. Instead of plugging in numbers and calculating it, that would take way too long. And so this goes over asymptotes, which I went over in the first video. So x cannot equal 10. And at each of the following values of x, select whether f has a 0, a vertical asymptote, or a removable discontinuity. Okay, so if we plugged in a 2 in the numerator, we would get 4 minus 24 plus 20, which would get us 0, right? And anything divided by 0 divided by anything is going to get us 0. It cannot be a 10. Removable discontinuity is when we basically can remove that. It will not equal. Let me show you a better example. One moment. Here it tells you what is removable discontinuity. It's when a type of discontinuity of the function that occurs at a point where the graph of function has a hole in it. This point does not fit into the graph, and hence there is a hole or removable discontinuity. For example, there. So x cannot equal that number. That's what that's what discontinuity is. Here's a good definition of the difference between the two. The difference between a removable discontinuity and a vertical asymptote is that we have an R. Discontinuity if the term that makes the denominator of a rational function equal to 0. So for x equals a, cancels out under the assumption that x is not equal to a. Otherwise, if we can't cancel it out, it is a vertical asymptote. So if it can be canceled out, it's removable discontinuity. So that here the denominator cannot equal 13. Okay, so for the numerator, if we were to plug in a negative 3, let's see, what would we get for, we would get 0 over whatever, which would just get us 0. Let's plug in a 7. I'm just plugging it into my calculator. We would also get a 0. Let's look at this one. I think there is some confusion between the vertical asymptote and 0 when it comes to Khan Academy. I don't know, it's just a little different compared to what I am used to. So let's look at this one. Okay, so inputs where the functions is defined. Okay, so actually let's check the denominator with negative 13 and see what happens. I think that's where it is going incorrectly. So that would get me 169 minus 4 times negative 13, which is negative 4 times negative 13, which is positive 52. So you would see you would get a number in the numerator, and in the denominator you would get 0, which would be undefined. Inputs where the function is defined and the numerator is equal to 0 are zeros of the function. These are simply the x-intercepts of the graph, okay? Now that we simplify, now we can simplify the function expression by canceling out common factors Any undefined input that no longer makes the denominator equal to 0 is a removable discontinuity. The remaining undefined inputs are vertical asymptotes. So, oh, it looks like they factored first the top and did it different. So let's see if we factor the top. So maybe that's what we should be doing first. What two numbers would we get? 7 and 3. Okay, so I would then have x minus 7 and x plus 3 over x plus 13. Okay, so since these cannot cancel out, that's when it would be a vertical asymptote. So that's what they are saying. So when it can cancel out, that's when you have removable discontinuity. So that's the difference, and that makes it more clear. Okay, so here you're just graphing them. You can just plug in values for x equal, see what the denominator cannot equal. So you can find the asymptotes. We already went over to find the asymptotes, and then you would go from there. Pretty simple. If you do need additional videos, let me know. I'm just trying to get to quiz 1 here because our videos can only be 15 minutes in length. And then here you have word problems, which involve reading comprehension and understanding. And you can always look to see how they are done. If you have questions on any specific ones, please let me know. And that's pretty much half of the unit all the way up to quiz 1. So, try to get in the gist of things and see how you do. And if you have any questions or need any additional help on anything, just let me know.